Okay, so we'll talk about one of the key things that happens in any data science modeling process, which is often ignored reality of model governance, right? So fundamentally, uh, we uh, we kind of data scientists have this habit of wrapping up the model and focusing a lot on algorithms, but one of the major things that get missed out in this process is model governance. A lot of banks and financial institutions, traditional companies have had a very stricter process of governance, but sometimes I've seen the new age startups, not following governance and not validating the model enough, before the deployment happens, and that could have fundamentally a lot of risks. So that's what we are going to talk about it today. Yeah, so if you look at data science, right, there are two uncertainties, right? One I would like to call as a mathematical uncertainty. So I'll give an example. Let's say we want to predict, who's going to buy a given product, right? Now, whether you will be able to predict or not itself is an uncertainty, and that is what I would like to call as mathematical uncertainty. Once you pick the data and then you build your model, that's when you move from a lot of uncertainty to certainty. Then the second part of this is intervention uncertainty. So we are not just building machine learning models for model's sake, right? Like, we are building it to have an outcome, right? So for example, just to take the if somebody were to build a predictive model on probability to purchase, right, on an e-commerce website. So let's say there are a bunch of folks who are coming on the website and they want to predict who's going to buy and who's not going to buy. Assume we built an offline model and then that model was good, and that mathematical uncertainty part of it is taken care of. But how do you know whether whatever interventions you are doing, right, in order to either make a person who has a 70% chance or a 90% chance of buying by giving offers, or make that person buy more, etc., right? So those where the interventions start playing. Now, whether those interventions will make a difference or not, we cannot do unless otherwise we start experimenting and we have experimental data, etc. I'm able to predict which movie you would like, is one part of it. But second is when I show it right to you on the home page, or when I send you as a push notification as a movie to watch, whether that intervention itself will work, is the certain is the intervention uncertainty bit of it. So one factor is, we said there are a bunch of risks, right? And why should models get evaluated, looked at with closer scrutiny on whether models make it or not. First part of it is the uncertainty, right? Models are working in an environment of uncertainty. For example, contrast this with your engineering kind of roles, where there is a PRD that is written, and then you're working on a certain feature which is more predictable, right? Whereas when it comes to data science model, there is enough amount of both mathematical uncertainty and intervention uncertainty that is there, right? Second part of the problem is there is always a temptation of complexity, right? Now there is a tendency with people who are working in the field to bias towards complexity. There is all when there's a simple solution available and complex solution available, there is a human nature to bias towards complexity, especially if you are comfortable handling that level of complexity, right? So and complexity brings in itself a lot of practical issues. One is certain assumptions of parameters. Some of these features may not be stable, they may be things like feature drift, etc. And that builds another layer of errors, and so to say inaccuracies into the model, which needs to be well tested and hence well governed. Now, the other part of this is the way we kind of, do this whole, machine learning model is, we can simply get away saying this is non-explainable because this is a black box, and sometimes they don't come with very palpable measurements, right? So things like perplexity scores and Silot coefficient, for example, for LDA or clustering, etc., right? is very unpalpable to understand a model. Right now, these factors kind of contribute to why we need higher scrutiny, to understand things better and to be more robust and predictable in what we are in what we are building. So now, because of this, what is happening is there is a loss of revenues. I would like to say that because you have spent a lot of time building this model, then you measured them wrong and you measured them with opaque scores. You did not do your reality checks into the model, etc. And because of which your revenues kind of get lost, and you end up having poor user experience. You expose the model, let's say even at a 10% traffic, a bunch of your users got impacted because you did not do your checks well. And most importantly, people start thinking, okay, this is some well much more hyped things, and people start losing trust in the science of data science itself, right? So in order to avoid all of this is why we are going to talk about model governance today. So before I go further, are there any questions or comments that you want me to address? So the process to ensure the black box models produce expected results. So one of the things that I keep telling my team is forget about the model predicting something, because the model should be predictable, right? So you as a data scientist should know before the model goes live and hits customers and actually impacts their lives. And actually you take a cost on the company to expose the model to a set of your users. You want the model to be very predictable, right? You need to know, okay, whether this will give certain level of lift, whether this will cause a certain degrading user experience, will it end up cluttering people, things like that, right? Maybe it will spam more, or it will end up targeting people who will anyway buy and kind of irritate them more. So there could be a cost of user experience, or there could be some results which you kind of incurred a lot of losses because the model ended up targeting a set of people who were anyway not buying, and we wasted a lot of promotion budget on that, right? So there could be revenue impact, user experience impact, etc. So it's important that the models that as a data science team we are able to predict the efficacy of the model even before deploying the model, right? And of course, compliance and regulatory requirements, will briefly touch upon it. The world of AI governance, if we are talking about unbiased models that do not bias with specific to any demographic parameters, etc. Right? So that is the second part of the second reason why you need governance. So what does a governance process look like, right? So one is you establish some guidelines. You say this is how I'm going to test your model. Remember, just so there are two ways people look at it, right? Because there is models come with an inherent cost of both user experience and revenues if they fail and if they backfire. There are a lot of companies who hesitate taking any models for that, right? So there's a lot of block on taking any models live. They won't go with heuristics first kind of approach. However, we want to stay away from it. We want to take large scale non-linear models out there, and hence the governance process kind of ensures a lot of trust within the system and helps a business user or a founder to have that faith in taking this model live. So for that is where we come to a governance process. So one, you establish an expert council and provide guidelines, right? And second is following the governance process is also important. So that kind of makes it more stricter, and people don't get to deploy without enough audits and controls, right? So that's the point I was trying to say. Building predictive models is different from building models whose outcomes are predictable, right? So we want to build predictive models whose outcomes are also predictable, that we have higher confidence in them, before the rubber hits the road. So there are two ways to understand what's going on in a model. One is we assume kind of it's a black box. So you can either peep inside the black box, look at the nuts and bolts, and look at the wires and say everything is fine, or you can test the black box as a whole. So governance process kind of establishes you to do both. You have enough experts in your team, you should definitely do the left hand side of seeing inside the box on what is happening, and examining the models very technically as well. And that does not, even if you do that, that does not leave you from doing a step on the right side, which is testing the box as a whole. This is peeping inside the box, right? So here, this is where you actually, if you have a principal scientist or a senior data scientist in the team, and let's say a data scientist is building the model, it's better. I'm saying there should be two parties involved, right? So it can be a peer evaluation also. One person is building, and then another person is validating the model. That's important to have at least a peer review, another pair of eyes checking the model. If that's possible, that's always works. It can be, somebody at a principal scientist level, etc., could make a difference, because these people understand the fundamentals of machine learning, which some of the people who are just getting into the field may not have as much as depth. So it kind of makes better sense to have somebody with more experience evaluating the insights of the model, right? So those would be, what are the features, right? Sometimes you could ask questions like whether a certain feature is really required, and what does the model saying as top features, right? And are the top features making a difference or not? Because one of the things that normally people do, especially when it comes to top features, is that there can be a point where there are certain features that wouldn't even show up in your when you go deploying, right? So it's called variable leakage, right? So for example, if I predict that you are going to buy, and if one of my key variables is adding something to cart, it's not adding any value to you, right? Because you have to buy after something adding to a cart. So some of the features level discussions can happen. You do check a lot of correlations between the variables. Do you ask yourself the question, is nonlinearity very important, and nonlinearity explains some of these things well. I talked about the leakage variable example. Whether you have taken a right choice of algorithms. So it's a person who's extremely technical, deep, asking these questions to the person who's built the model. And before that process kickstart, it makes sense to put them as guidelines, so the organization agrees that, hey, these are the guidelines that we will follow while building the model. And you build your model and write this document of why certain features were picked up, how did you do your correlation test, what kind of assumptions you made in the model, what are your top features, and do you think your top feature justifies what you're predicting, why did you make certain choices of algorithms, and why not certain things. So all of these, somebody could also write it, and before that, a senior person could write a guideline document across the company, so that whenever a new model is built, they could follow this. So if you just look at this, right, so one of the common thing in features are missing values and outliers, right? So when a value is missing, it is not wrong always. It's not like somebody failed to capture. A missing value could in itself indicate something. So I'll give you an example. Let's say last 3 months purchase of a user at a user level. Now, if that is missing, that means that the person did not buy anything in the last 3 months. So there, the missing value is indicating something. It's not a record to be ignored, but a record that has a lot of information. It says that the user did not do anything, and hence it's missing. So anytime there is a missing value, the data scientist should ask themselves, why is this happening? And is there a flaw in the pipeline, or is this expected? Do we expect certain distribution of missing values to increase in future, right? So for let's say we are collecting income is one of the predicting variable, let's say of propensity to take a mutual fund. Now, this income variable, how are people collecting it? Is the collection mechanism of gathering this information going to change in the future? Will Now there are understandably higher missing values because people are not ready to give these values, but will there be a mechanism in future where we try to reduce the missing values, right? So it's important to understand those context of these variables, and then you understand, after this you say, okay, this is how I'm going to treat a missing value. So in the first case where I said the last 3 months purchase history, if there is a missing value, I would always put it as a 0. And in the second case that I'm saying, where income is missing because the user was not comfortable giving the income, could either have a mean imputation kind of thing, or if it's a very important variable, we kind of ignore that record also, right? So either you impute based on certain techniques of imputation, or you, in this case, you could even ignore that record. Outliers, similarly, when you see very large values, first question is, just because it's a large value doesn't mean it has to be ignored, or it's a wrong value, or it's wrongly captured. There can be reason to it. And how do you cap them? Will you be seeing these outlier values in future? What is your capping mechanism? Why did you take that kind of capping mechanism? What kind of discussions you have had with other teams who are facing, possibly who are more closer to the front line than a data scientist is, and kind of understand when certain things are when certain things have larger values or smaller values, what happened, right? And the context around it. Now, is the organization going to take any and if we assume that missing and outliers are happening because of certain systematic issues, then will there be any fix towards it? And based on it, you fix your model. Because see, once you put the model in place, the distributions that the model learned holds true, right? Unless otherwise it's a model that learns every now and then. Generally, it's a the base level model that you are going live with, and once you fix that, right? So till you replace the model. But and deployment generally takes 4 to 6 weeks, and then the model, let's say, slowly gets ramped up in 2 to 3 months, right? So we are easily talking about 4 5 months for us to make any change to the model. During those 4 5 months, if any of your pipeline issues that you had earlier got fixed, then the model may not hold well. So it's important to ask these questions before we start deploying the model as part of the governance process. Now, interrelated variables are another interesting thing. These are your correlations. Some of the nonlinear models can handle, correlation, but despite that, we want to understand whether these correlated variables make sense. Like, if age and income are correlated, are they showing a pattern? Like, up to a certain age, income is increasing, but after that, it is decreasing, right? Or it's going up and down. Why is it going up and down? So some level of investigation on this before we get to the algorithm will kind of give some insight into whether the variables that is flowing in are authentic. Are there been bias in certain collections? Like, are we getting data only from certain people? Like, some people with higher income possibly are comfortable revealing their income, or maybe some people with lower income are comfortable revealing their income. The people at either end of the spectrum do not give income levels, right? So, and hence you may see this as a pattern when it comes to age and income, and hence you kind of now think whether it's a good enough variable to model or not good enough to model the variable. Then are there, so what is the right strategy? So hence, should you keep these very correlated variables? Which variable should you drop? Which kind of algorithm you should use? Because if you have too many correlated variables, should you do for possibly a factor analysis and then start building your models? So those are some of the discussions and active thinking that happens within the data science group, but also involving their counterparts in business, product, or whoever is facing the customer, in order to be sure that what you're building is robust. So this is one I explained in the first slide, peeping inside the box, leakage variables. Variable may not be available. Sometimes the variable is not even available at the time of prediction, right? So and using that variable inside the model will give you a very false notion of your accuracy, right? For example, let's say predicting the purchase propensity of the user for the next day, right? If already you have data of next day flowing in your training data set, right, then you're not predicting this correct. So where you cut, so if, for example, let's say in the real world, I want to predict whether this person is going to buy or not buy next day, right? But in my training data set, if I have variables like whether the user visited the website for the next day, and whether they had X number of logins or some time spent in the website on the next day, then in the offline you will have all this, right? But real time you're trying to predict it for the next day. So you will not have these variables, right? So that is called as leakage variable. So that is when you list out your top features and see whether these are very practical variables, whether they're going to be available, or there is some level of leakage that is happening in the model which is exaggerating the offline accuracies. Or sometimes people, the second common mistake people make is they do a lot of transformations on the entire data set, then break it into test and train data set. And when they do it, certain kind of techniques make leakage between the training and testing data. So for example, let's say the missing values we talked about, if I'm going to impute the missing values with the mean of that value, let's say I'm imputing age, right? So there's an age variable, 10% of age is missing. So put mean of my entire distribution in that. Now, when I'm calculating mean, I should have calculated only with my trained data set. If I had calculated mean also using my test data set, that's called a leakage. So tomorrow, if your test data set, if your real-time data set has certain distributions which is different from your overall data set, right? There the model will fail. But in your actual, when you actually did it offline, it would have shown you a higher accuracy, so to say. Now, the fundamentally those few slides that we saw, the last 3-4 slides, have been on extremely technical measurement, which data scientists you need. Like I said, at least you need a senior data scientist to measure the impact of what a entry level scientist has done, right? Or if you're working with a group of interns, you definitely need that level of governance. But that's one part of it. The second part of it is much more easier to understand, which is measuring the box as a whole. You're not peeping inside the box, but you're testing the box as a whole. What you do here, you kind of exactly take multiple data sets, right, and do not mix them. Multiple data sets, and then you keep on testing your models across multiple data sets. But you need to know what you're measuring. So that measurement criteria is very important. Again, these can be technical measurements like AUC, AUC, PR, F1 score, precision recall, etc. But they can also be very practical measurements. Like the example, let's say we took on recommendations. So I'm going to recommend 3 products in an e-commerce website in order to increase the conversion rate. If I have historical data that these people anyway bought those products, so I can simulate and see across my multiple data sets if I would recommend item A, item X, and item Y, for that user, and I know in future what they bought in my offline data set, I would be able to predict conversion rates, right? So conversion rate becomes total number of items bought by total number of visitors or total number of sessions, etc. So you come up with a very front-ending product or a business metric to measure across these different data sets, and then compare, okay, now I know roughly this is how the conversion rate is going to be and I'm comfortable with it. We also baseline, so we also kind of know that this will be better than what we are doing today, and hence you take a call on, okay, this is good enough. So this is more business metric, we call it, like something very closer to what really practically things impact. That is one way of measuring it. The second way of measuring the box as a whole is also making some of these technical measurements, like how accurate your predictions. Well, let's say you're testing a conversational bot, how much accuracy it had, right? Whether the user felt, when you tested the bot as a whole, you felt you had a relevant conversation or not, or whether the responses that the bot provided were very expected to the responses that you would have otherwise thought of, right? So then your precision and recall fundamentally more precision or accuracy kind of metric comes into picture. Whereas in the example that I said in e-commerce, it is more about a business metric. But however, technically we measure if it's a binary class that we are saying whether buy or no buy. We use measures like AUC, and if there are multi-classes, like a lot of classes the model is predicting, then we come up with a score like F1 score as a technical measure. And correspondingly, we should have a business metric that's more understandable and hence more palpable as a model measurement. So model metrics may not guarantee correlation with business metrics, right? So business metrics are like, you may think this can have a higher conversion rate, but sometimes it's possible that the technical metric that the model gets measured on does not have correlation. So sometimes these things do happen. And again, some of these are happening because of the first uncertainty we talked about, which is more on intervention uncertainty. We do not know whether some you can recommend, and that recommendation may also be relevant to the user, but I may not watch the movie, right? I may like your recommendation, but I may not watch the movie. A lot of more factors than your recommendation. I should have time for that. My internet connection should be fine. I should be in the right setup to watch it. My there shouldn't be a function going on in my family, in which case I don't get an alone time to watch the movie, right? Or maybe I'm with a bunch of friends, who would want to watch a certain different type of movie. There might be personal preferences, right? So these things kind of determine your intervention uncertainty, and hence, though your model might perform well offline and everything, but it may not have a correlation with business metrics, right? Model metrics does not measure, or identify. Sometimes it's also possible that the reason why your model metrics are not correlating with your business metrics is that when you formulated the business problem to a technical problem, that there were gaps, right? So those could also be found out. Again, all of this can be done offline, and then say maybe this is the difference, or when some of these differences come up when you actually go live with these models. So we talked about it. I want to iterate again on the business metrics and baseline. So baseline is very important. So any machine learning model is not taking you from to 99% accuracy, because a lot of people think machine learning models will give you, is better only if the accuracy is 99%. It does not make any sense, right? Because if your current state of the affairs, that you are at a certain level of accuracy or precision, let's say you're at a precision of 70%, and the model takes it to 75% also, there's a 5% lift you're getting, right? And hence it's a good enough decision for you to take the model. So no machine learning model should be measured without a proper baseline. Every technical measurement comes with its own baseline of random choices, and if model makes a choice, how will that be different? So those are technical measurement. But business metrics also, if you have an existing recommendation system which is based on heuristic, frequency distribution, etc., they become your baseline, and then you measure your model on top of those and say, if I'm making an incremental lift. So let us say current recommendation system, number of people who are clicking on it is only 5%. But if you put your model and that increases the click rate by take the click rate to 5.5%, it's only 0.5%, but at volumes it may still make a big revenue difference for you, and hence we take it. So establishing the baseline either through a random mechanism or whatever is there in current solution, or sometimes it is no intervention. So for example, I am not putting any offer or campaign on my website, so I'm getting 500 sales a day. Now I'm putting an offer, on top of it I'm putting a model. Now my sales, how much it increased, right? If it increased from 500 to 510, right, and the 10 would have anyway come if I have just put the offer and I did not need the model for targeting. So the model is not doing much here, right? So hence, what is your no intervention stage, when you do not spend money on it, or when you do not show the recommendation widget? What is your conversion? So when you show the recommendation widget randomly, what is the metric? When you show the recommendation widget with a very naive logic, what is the conversion? To when you show it with a machine learning model, what is the conversion, right? So it should progressively increase from no intervention to intervention based on a machine learning model, right? So sometimes it's also possible to measure trade-offs of false positive and false negatives, right? So when you predicted somebody wrongly, saying this person is going to be a fraud, or when you left off a fraud without catching them for the fear of user experience, there is a cost to it, right? So you simulate that cost offline, and then simulate the cost offline for your as is condition today, right? Maybe your operations is manually identifying the fraud, to a machine tomorrow is identifying the fraud, and then you say, okay, is there an improvement of false positives? Is there an improvement on is there a decrease in the cost of false positives, or what kind of trade-off are we getting between the baseline version which is there today to what it will be when you put the model, measure that offline, and then take it to deployment. We'll now quickly touch upon who constitutes a governance cycle. So all of this is good. Let's say we establish guidelines. We have a peer person to look at how the models are. There is a sign off, and then only it goes live. So let's say if it's a little bit larger setup than maybe a few member team, how do you ensure as execs or founders in a startup, in order to make sure that this process is happening, is indeed these checks and balances are happening? So you make a small council of people called the governance council, and they are experts in data science. They have enough knowledge in data governance regulation. They have authority in the company to say, no, I will not let this model go because this could cost user experience. We may still get a lot of revenue from this, but this could cost user experience, and hence I will not be able to allow this model further. Hence they should have authority. They should also understand business context and stop being bureaucratic, right? It's not about introducing a bureaucracy layer, but a layer that works in the interest of the company, but at the same time has a larger picture and cares for the welfare of the organization, also welfare of the environment that they are part of, right? Especially those companies which are running marketplace where fairness is very important. It is the council that's going to come up with these matrices to ensure fairness and test your ML models against these matrices and do a go no go decision on that. See, there are no solutions, as they say. There are only trade-offs. It's a cost benefit that you do. You try to get the best trade-off that you can get, and that's all you can hope for. So it's very important in a governance process. There is a trade-off between efficiency and trade-off between speed. So governance council, like in large organizations, cannot afford to lose speed, right? Like it cannot it cannot be a stopper. But at the same time, it has to keep the long-term interest and compliance cost and people's trust in mind while approving or declining the model. So it's a matter. Hence the governance council as well as the entire governance process should know the right trade-off between efficiency and speed. So that's all I had in the slides. Would love to hear your thoughts. If there are any further questions, I can answer them.
Yeah, hello. I'm Alex Paul from AI Touch Highway. Yeah, just want to go back to this one, data, finding the data outlier. Today, we are working mostly with, can you hear me?
Yes, absolutely. Go ahead, Lex.
Actually, we are working with the health related data. So sometimes we encounter some of the pathological conditions which are very rare. So when we are creating a model, we come over most of the usual data that has lots of variance, but we are able to club those things together. But there are some cases in which we find some pathology that are very rarely occurring. So if such condition comes, then how do we make our model understand that that is also to be considered, and then we have to consider for this one in the model. So is there any way to do that?
So I think your question is how do you build a governance process or model validations when there are rare events, right? Rare occurrences.
Yes.
Yeah. So see, there are first techniques where you bootstrap your data set, as you know. So you should have oversampling, etc. There can be again two possibilities here. One, you have a ground truth data. Second, you may not even have ground truth data, right? If you take fraud examples, right? There are one, their occurrence is rare. Second, the ground truth, when we don't know whether a transaction is fraud or not, is generally a possibility, right? So a lot of effort does go in creating ground truth data, but let's say you have ground truth data, but just that they are rare. Then there are modeling techniques like oversampling the data, your smart, or increasing weightage penalty for predicting your rare data wrongly. You could use those penalties while building the machine learning model. So you can have class weights that kind of increase the penalty for an underrepresented sample. So either in the sample you boost them, that's a very common traditional technique, or while building model you increase the penalty, as part of your cost function, and hence train the model. While testing the model, what you do is you look at very specific metrics for that, right? So if it's a very biased sample, and it is a binary class. AUC-PR is recommended, right? AUC for precision recall curve is recommended. And similarly, you could look at your recall, or you could look at your precision metric, as the case may be. Those two you could look at, and you in your confusion metrics, you can come up with a cost function that says, hey, I'm going to penalize my false positive so much, and I'm going to penalize my false negative so much, etc. Right? And you work out a mathematical cost function, very not mathematical cost function for a business metric, right? So if I predict, if I leave a fraud, let's say I lose $1 million, right? But if I kind of call someone who's not a fraud as a fraud, I'm impacting their user experience. Maybe they will not come back and buy, and hence their lifetime value is lost, right? So between this, you will be able to arrive at a single metric that can give you the trade-off, and that's one way to measure it. To model it, you use, there are very specific techniques to model undersampled data sets, so you could use that. I hope I answered your question, Alex.
Yes, actually, we also have encountered some of the problems. Like the thing is, some of the data, what happens, it is very rare, but the thing is, some of the characteristics are very similar to some other data in the database. So we are sometimes, like, we grade them to that level, but sometimes it causes the other data to be misclassified. So that challenges we are facing. So yeah, I think we'll try with the model and see it out. Yeah, thank you very much. Yeah.
Sure.
Oh, I have one question, just a small question. So currently we are dealing with the unstructured data and all the things that were regarding the model governance mentioned. I think mostly that relates with the structured data. But when it comes to the audio or image format, how does the model governance works over there?
No, it works for this also. See,
Okay.
even if it is unstructured data, even text or anything, so some of the precision recall metric, if you have multi-class, see, it finally becomes a classifier, right? Unsupervised is different, right? So if it becomes finally a classifier, then all of your AUC and all of that metric is important. Then you do your kind of precision recall score, or if it's text data, you can do your blue score or word similarity kind of scores. But in your context, you would know whether accuracy is your important metric, if it's how similar a sentence to another sentence is important for you, or if it's about classifying, let's say, a bunch of images, then it's again kind of accuracy that is at play. But if again a certain class is predominant, then you will go for some of the things that I'm saying, like AUCPR or something like that, where all of these metrics will again come into play. Unsupervised is where the difficulty could happen, right? There also, what you do is you take some set of data and then you do relevance, judgmental, accuracy checks if it becomes unsupervised.
Got it. Yeah. Thank you.